All right, let's try reviewing transformations. Let's imagine we have a function g of x that is a transformation of f of x. We should be able to write it in this order and write it in a factored form and read from left to right the transformations that are taking place. We would have a vertical reflection or reflection across the x-axis if a is negative. The horizontal transformations we'll review are reversed. Just like if you have a quadratic expression that has a factor of x minus 3, that doesn't subtract 3 from your x value. It means your x values can be 3 more. We'll see that same reversal here with this k value. If k is negative, we have a horizontal reflection or a reflection in the y-axis. We have a horizontal translation, right p, assuming p is positive, and up q, again assuming q is positive. Let's say that we are asked to sketch g of x equals negative 2 times the square root of negative 3 x minus 12. Why don't we go plus 5? I would suggest beginning by listing the transformations. Before we do that, we need to write this in a factored form. I see these are transformations of a parent radical, but I want to have a positive 1x so that I can read off those transformations. So let's do that. G of x will be negative 2 times the square root of, I'm removing a factor of negative 3, leaving me with x plus 4. I can always check with distribution. And then reading in this direction from left to right, I see that we have a vertical reflection, vertical stretch by a factor of 2, horizontal reflection, horizontal stretch by a factor of 1/3. If I'm tripling my inputs before I take their square roots, then my inputs can now be 1/3 of what they used to be. Likewise, if I'm adding 4 to my inputs before I take their square root, my inputs can now be 4 less than what they used to be. So we have a horizontal shift, left 4, vertical shift, up 5. Let's draw a sketch of our original parent function. It's a parent radical. Let's draw it vertical out of the origin. There shouldn't be any memorizing here. This is the square root of 0 being 0, the square root of 1 being 1, the square root of 4 being 2. And then on my sketch, I will perform those transformations. So vertical reflection, something like that. Vertical stretch, I'm not too worried about getting a high level of precision for just a sketch like this. I also know that these stretches don't affect my domain and range. Here's a reflection that will affect my domain. The horizontal stretch by 1/3 might be one of the trickier ones to do. I'm going to try to third the distance that each point is from the axis. It just makes my curve very, very steep. I'll fix that on my final copy. I shift this curve left 4 and up 5, and it'd look something like that. This is a little bit crowded, so maybe I'll do a good copy over here. There's the origin if I want it, left 4, up 5. This is a pretty important point, so let's label it. And then I will draw a curve that is vertical at that one instant and going down and to the left, like on my rough sketch, down and to the left. I can tell from my sketch, and I would be able to tell from my equation as well, that this curve doesn't have a y-intercept. There will be an x-intercept that I can find by setting g of x equal to 0, but I wasn't asked to label the intercept, so I won't worry about that. What I do need to make sure that I label is the curve itself. The name of this curve is g. And there we go. From this sketch, I can state the domain and range and do all sorts of other stuff. Try that out.